Hey, how's it going, class? This is Mr. Miles coming at you with another podcast. I guess they are back by popular demand as long as the 7th graders actually want to take the time to watch them. Then I will take the time to do them. So, what we're talking about right now is we're talking about the sky from Earth. This is just lesson 1. And lesson 1, it's pretty basic. A lot of the stuff is things that you already know. It's once we get into further lessons, you're going to start to learn some new concepts. But we can have a lot of fun with this stuff, even though we already know it. I think the whole thing with space and the cosmos is a really fun thing to learn about. So, let's do it like this. Start off with a picture. And so this one is our everyday, call it our sun. But also, our sun, and you guys know this, our sun is a star. When we look up in the night sky, we see stars all over. The thing to understand with stars is what we talked about is it's a giant ball of hot gas, and it's mainly comprised of hydrogen and helium. And what these things are doing is they're actually going through nuclear reactions because it's gravity versus the force of these two gases expanding and exploding, so pushing outwards, and then gravity pushing inwards, and that's what keeps stars stable, so that what keeps us from either blowing up or the star burning out. And that's pretty much what makes up stars, and all stars are like this, and you can have different sizes. There are actually some stars that just completely dwarf ours, that make, another star the size of a basketball makes ours smaller than the size of a marble. And so, again, when we learned about the other day is that space is extremely, extremely huge. We learned that if the sun were the size of a golf ball, if it was 5.5 inches, that our Earth would be lying about 50 feet away if we scaled it down to that size. And that's pretty far. And also that, Jupiter was half a mile away, we figured out. So our universe is expansive, and the sizes are absolutely ridiculous. Now, rotating around our lovely sun lies planets, and one of those planets we like to call home. And what these are is they are giant objects in space that were large enough to be rounded out by gravity. And you can have different types of planets made of different types of material. Now, the thing to understand is that planets are actually quite rare because most of the material, by the force of gravity, would get pulled into making up the mass of the star. But luckily in our solar system, for our sake, it didn't happen, and we are able to exist. Now, rotating around our planet and other planets in our solar system, now we only have one. We call this a satellite. A lot of you might have said, oh, it's a moon. Well, no. The correct term is we call it a satellite. And what this would be is this would actually be a natural satellite, meaning we didn't make it. It was formed there by nature. And so that's what you call it. So when you're looking at Jupiter or Saturn, the correct way would be like, oh, those are the natural satellites. But then we'll have names for ours, just like we have a name for our star, which we call the sun, and our moon, our satellite moon, and Luna. Now, we also encounter a lot of other different things that are taking place within the night sky in the solar system, and we get used to seeing things called meteors. And meteor is simply something that has entered the Earth's atmosphere, and because it enters the Earth's atmosphere, it deals with this friction, and it gives it that nice jet across the sky. And the reason you're seeing this is because, remember, air is actually something. There are molecules of air, and it causes friction, and so it causes the meteor to start to burn, and that's why you see that streak across the sky. Now, this is actually the concept that got some students confused with how comets operate. Okay, come on, go to the next page. There we go. So I asked you the question. I said, if here's the sun, and here's Earth, and there's a comet headed in this direction, which way would the tail be pointing? And a lot of you guys said, oh, it'd be pointing like this, because that's the direction it's heading in. And remember, this tail is caused by friction. So wait a second, but there's nothing in space, so there couldn't be any friction in space. That's why actually the tail, even though it's going that way, would point the same way it's going. Because what's influencing that, that tail is actually the sun. Because remember, space is extremely cold. It is very, 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 very cold. Whereas the sun is very, very, very hot. So it causes ice to start melting and some of that dust to blast off. So actually, if it was relative here, it would be going off like that. If it was here, the tail would be shooting out that way. If it was here, the tail would be shooting off that way. So, a little fun thing to learn about comets. Now, the other big thing that we see inside our solar system is we see something called constellations. And what a constellation is a constellation is just simply a group of stars. So it's a group of stars that we use to make a picture. Now, we were kind of laughing at the fact, if you look in your book, it's on page 7 when we were doing the Apply This work, and we looked over at the one with Cassiopeia, and we kind of laughed at the fact that, somebody said, well, wait, Cassiopeia, that doesn't make any sense at all, because Cassiopeia is simply stars like this. And please tell me you can see this. You can definitely see, look, there's a lady, look, she's combing her hair, right? You guys can all see that? No, you'd say, oh, it looks like the two mountains. You just kind of turn it on its side and put that up. But no, what it usually is they look at that, they kind of give it a, kind of story behind it. And so I'm sure there's some sort of story behind it with, some Cassiopeia combing her hair, something famous like that. I'm not an expert when it comes to constellations. But usually that's how it goes. But you have other ones like probably Scorpius. That looks a lot more like, you can say, oh yeah, I can see the scorpion in that one. Ursa Major, you can see that one. And Cygnus, you can see that one. You can easily see how that could become a bird. Now, it's actually fun because I showed you guys that thing on my tablet of how you can use that Stargazer, and I know iPods and Androids, they all have stuff for that. I'm sure the other kind of brands of phones, as long as it's a smartphone, they can do that. And so if you ever find yourself in a place that's not afflicted with a bunch of light pollution, so Vegas is not a good place because there are lights, there are lots of lights, so you can't really see a lot of stars. But if you go somewhere where there's not a lot of lights, then you would be able to see all these different constellations. So you bring one of those, you bring your binoculars or telescope, and it can help you find different things. Because even you can see some of the planets up in the sky. And Venus is actually going to be the brightest thing that you see in the night sky other than the moon. So it's pretty cool to be able to see distant planets. It almost feels like you're on like an alien world when you're staring up into the sky. Now let's see, the next thing that was important that the chapter covered was how do objects appear to move in the sky. And remember, we talked about this, and I think with my 5th period it was, we kind of picked on Tucker, and in the 1st period we kind of picked on Alexis, and we said, you're sitting there and you're watching, and, say, you're sitting there with your boyfriend or girlfriend, not now, you guys wait a couple of years, and you sit there and maybe you name your star Frank. You're like, oh, honey, that's our Frank star. And what you're going to see is throughout the night, he's going to start to move across the sky. Now, the reason they move across the sky, and, what people originally thought the reason he was moving across the sky was because that the stars are actually rotating around the Earth. Now, we know now that that's not true, but that's what they used to believe, is the stars are moving around us, but we know that we are rotating, and we are moving through space, and it's causing our position to change, making it look like that. And the thing that it's not important to know right now, but just one of those fun facts to know, one of the things that helped them lead to that discovery is when they were dealing with planets. So if they looked here and they looked at Venus, they would notice something strange. It would start to go across the sky, then it would stop, come back, and then go back this way. And that's what we called it retrograde motion. And that kind of stops the whole idea of, so you're telling me that a planet decided that it got here, didn't like what it saw, went back, but then decided, why not, I'll try it anyway, and then kept going. Well, no, that's actually what helped lead a lot of astronomers to realize that, hey, there's no way on Earth that all these things are rotating around us. So, another thing that you're going to notice, not only do they move across the sky, but depending on the season, they're not always going to be in the same places, and you're not always going to be able to see the same constellations in the same places. And we're actually going to learn a lot about why this happens on our on the lab that we're going to be doing tomorrow. And that also explains, not only does it explain the amount of, oh my goodness, my phone is going insane, sorry. Not only does it explain why we see different constellations on different parts of the Earth, and why we see it during some seasons where we don't see it as other seasons, but also explain, why it's hot during the summer versus when it's cold during the winter, and why it switches, and why people in Australia have different types of seasons than we do at different times of the year. And so that's pretty much all the stuff that we talked about today. Anything else? Again, I would always encourage reading your book, because there is some other parts of information that I do need you to do to help you get prepared for the test. Again, if you're not reading your book, it's really going to hurt you when the test comes, because we don't cover everything in as much detail as you guys would probably need in order to fully understand everything. So again, if you ever have any questions or comments or concerns about what we're learning about, feel free to email me. If you want me to make an additional podcast on any of this material, let me know, and I'll go in more in depth in anything, because this is kind of just a brief overview just to make sure that you guys understand everything that I'm talking about. But until next time, you guys take care, and I will talk to you later. Bye. Oh, I don't want to say changes.